Hello and welcome back to the channel. What I'm going to do in this video is do an explanation of what 3D printing is and some of the things that we create. And I'll talk a little bit about the printers that I have here with me, the printers that I own. So what 3D printing is a technique of taking plastic. This is 1.75 millimeter plastic. It comes in spools like this, and if you notice behind me here, I've got several boxes of filament. What we do is we take the filament, we run it through an extruder. The extruder gets really hot, and then it extrudes out little strands of plastic just like this, and it extrudes it out into a layer. It looks like this. It's very thin. Onto the heat bed. Some 3D printers have heated beds, others do not. All of my printers have heated beds. It's one of the things that I like about them because it gives me flexibility to be able to print a multitude of different materials. Some of the materials that I have in front of me today, I have PETG. This is food safe plastic. I made a bunch of cookie cutters out of it. I've got some ABS fidget spinners that I've built. They just have some, skateboard bearings in them. These are models that I downloaded off of a website called Thingiverse. So I just download them, print them. I've also printed my own 3D printer components. So normally the Prusas either come in black or orange. If you notice, this one here is a black one. This one is actually my Mark III's, which is one of the latest versions. This is a Mark II's, which is one of the oldest versions. And this is for a Mark 2.5's, which is what this blue one is behind me. I'm going to be upgrading this printer in a future video, and I'll talk about that upgrade in just a minute. But one of the things that 3D printing allows us to do is design things in CAD software or computer aided design software and manufacture them here in a hobbyist environment. It also allows us to manufacture things that we can't manufacture in a conventional means using conventional machine tools, such as an item like this, which is a spinner, but if you pop it apart, it has a herringbone design. So I'll pop this one apart and kind of show you what it looks like. And the reason that you can't manufacture something like this out of metal in one piece is because it's captured. So there's a gear that's on the inside here, and then there's also this little gear here. It's a herringbone design. Okay. When you design something like this, it can't be manufactured out of metal and then put together. It would have to be put together with screws and hardware. It's just kind of a trick way of manufacturing something. It's plastic. It'll hold up a little bit, but not as well as metal. It's a lot lighter. It's also very good for testing designs. For example, my robotics teams, I have a high school robotics team and a couple middle school robotics teams. They all have access to 3D printers. My high school robotics team actually uses these that I have here behind me. What it allows me to do is have students design a widget, and then they'll send me the part file. I'll put it into what's called a slicer, which is a program that dictates what each level of the extrusion is going to look like. Okay, And then that will get loaded onto an SD card or a Raspberry Pi. One of these has a Raspberry Pi on it. And then that will run the print job. Typically it'll run overnight. Something like this will take around 4 hours to run. Something like this is around 3 hours. It just depends on how dense it is and how big it is. Alrighty. So it allows me to bring the parts into the school and say, here's your design. We can test it out. If we need to manufacture it out of metal, at least that they've then tested the concept out using something that's fairly inexpensive. I can manufacture something like this for, 10 cents, I think is what this would cost. So it's fairly cheap. Also, one of the other things that I do with the 3D printers is I'll make motorcycle frames for my friends in my Shadow Riders America group. So they can contact me and say, hey, I want a plate frame that says this on the top, this on the bottom, these are the colors that I want it. And I can manufacture that and get it turned around pretty quickly. So lots of flexibility that comes with the 3D printing. I really enjoy it. I enjoy the creative aspect of it. I enjoy being able to manufacture devices like this. When COVID happened, I manufactured the face shields for several hospitals. I was part of a larger group from Matter Hackers that actually manufactured millions of these face shields and sent them out to people that needed them. I've manufactured a couple of hundred of them using these three printers that I have here. All right, so let's talk about the Prusas. Now, if you know me, you know that I picked the Prusas a few years ago, and I'm a diehard Prusa person. There's a lot of other 3D printers out there, and I thought long and hard about it because a Prusa printer is pretty expensive. This one was about $650 brand new. This one right here is almost $800 brand new. So, and they come in a kit, and if you get it assembled, it's another couple $100 for the assembly. There were several features of the Prusa that I liked over the other printers. One of them was the heated print bed that I talked about earlier. It's heated. It allows me to print a multitude of different materials. I've got 3 different materials in front of me, actually 4, because I have some flex filament that I use every now and then. But it can print several more, including nylon, which is pretty cool. I haven't experimented out with all of the different filaments. I haven't had a need to. If I have a need to, I know that I have the flexibility because the printer can handle it. So it's got the heated bed, but it also has a little Penda probe here, which is basically just a magnetic sensor. And what the magnetic sensor does is it reads points on the bed. There's 6 points embedded, or 9 points embedded in the bed, excuse me, that set the level of the bed. Now, if you don't have this, a lot of the conventional and cheaper 3D printers will have screws up underneath that you'll go around and you'll move your extruder around with your nozzle and you'll measure and you'll set the gap and you'll try to get everything just as perfectly level as you can. Whereas on this, the software does it all. It has a little sensor that goes around and measures the bed and it sets it level. So pretty easy. The other thing that I really liked about the Prusa printers is that the parts for the Prusa printer are open source. So if I wanted to modify something, I can modify it. If I want to make another printer, I can make another printer. If you're an eagle eye, you've seen that this motor here doesn't say Prusa on it. The ones on this printer do say Prusa. But all of the parts on here are off the shelf. There are very few things that are done especially for the Prusa. The frame it's got Prusa on it, but I believe that there are other vendors that are making these frames. The sensors, they're all off the shelf. The motors are LDO motors, they're off the shelf. These are just hardened steel rods. It's off the shelf. The bearings, all the stuff is off the shelf. I could literally go and build one of these printers. The cost is about the same as if I just ordered the kit from Prusa, and then I manufacture the plastic parts using my 3D printers, just like I did with this, which is what I'm going to be doing with this printer. I'm going to be upgrading this printer to match this blue one back here. I've already printed all the parts, so I'm ready to go with it. One of the other things with the upgrades that these two printers have that this one doesn't is that the beds are removable. So if you notice here, I've got a textured steel sheet in front of me. This works really well when I'm printing something like PETG. Now, PETG, if I were to print that on this surface, it would stick and glue down, and I'd have a double of a time getting this off of this bed unless I used a separation agent like a glue stick. But this surface, I don't have to worry about that. I clean this with alcohol, which I have spray bottles, print, let it cool, and it pops right off. It's nothing easier than that. This other print surface is smooth PEI sheet. It is the same surface as this, except for it's removable. Now, if you looking really close, you'll tell that it's cracked a little bit. I've used this sheet a ton. This sheet, I print ABS and PLA on it. The PLA is a very soft plastic. You can do a lot of detail stuff with it, but it doesn't really hold up. It doesn't really make functional models. It makes nice decorative things, but it doesn't really hold up to hard use. All right, I think that's about it. If you have any questions, please leave them in the comment section below, and I'll do my best to answer them. I'll go through and show a detailed breakdown of the printers when we get there. But yeah, I think that's about it for now. I like the Prusa printers. If you have any questions about them, if you have any design questions about the softwares that I use, please, comment below and let me know. If you want me to design something and print it for you, not a problem. I've printed hundreds of things for lots of people, so just drop me a note, let me know. I'd be glad to do that for you. All right? Okay, well, you guys have a great day. Thanks for watching.